So the Buchla Duophonic pitch class generator model 260E. And there's a 260 also.
Yeah.
Essentially the same module.
Which is what, David's first version of this was.
Can't help calling him Dave with that.
I know, that's
there. It's like, David. Yeah. And I thought, so quick funny story before we talk about the module. Because the 260 had Rogans, and then the 260E was demonstrated at NAMM 2016 or something, I thought the 260 was a vintage module. I thought that Barry Schrader had used it, like I've mentioned on this, but of course it's not. It was one of the first new 200 series modules. This is the 260 and the 297 were 200 series modules.
Yeah.
And the 260E is a 200E series module, and they were made around the same time. So craziness, but I wonder, that's where we are.
Yeah.
It's a crazy module. So
that it is. You had this at one point, and we're borrowing this one. And this one always perplexed me because there's that one video at NAMM that showed it off for about 14 seconds or so.
Yeah.
And I was just like, wow, that just sounds like circus music is how
it does. It does.
would always describe it. But I'm like, okay, let's get a little bit more background information on it, since you just heard us talking with David, and how this module in a way was just a mistake, or that's how we
and I think maybe the code is incomplete, and
just
in general, it came out in 2004, I want to say. It was when the 260 was, I might have the date wrong, but it was around that time. But the code in it is strange. And I have another quick funny story about that, the 260E. Do you remember I met you, Kyle, at that music thing in Seattle all those years ago?
Patchworks event, yeah.
Yeah, that thing. It was a long time ago. And the person that demonstrated this at NAMM, I forgot their name now.
Felix.
Felix, yes, thank you. They were at the show, at the show where you were. And I went over to their system and I was like, whoa, a 260E. I saw that in a video about NAMM.
And they're like,
and they go, yeah, that was me. It's like, oh man, felt like a total tool, but they were pretty nice about it. So yeah, I looked for one, and then I bought mine from the CTO of Red Hat, who had two 24U systems that Don had built for him forever ago. And now I think Alex Plininger of Keenan Associates.
That's right. That's
yours. Yeah.
And what's interesting to note is this one, this was shipped with the, if you're buying a starter.
Like the 18 and the 24.
200E system. This was the only other tone generating module, because they didn't have the 261E yet.
That's right. They had the 259E twisted waveform or complex waveform generator, which changed its name to Twisted later.
Gotcha. Yeah.
Which was like a 259 sort of that had been digitally altered.
Yeah.
It's crazy. It's hard to go back that long ago and try to remember everything that we've learned. But this module, if you can think about buying one of these Buchla systems in 2008, 2009, when they were still really expensive, put together by Don and some folks down in Oregon, shows up at your doorstep, and you have the 260E in it. Probably at the time, you would think, this whole thing is crazy. This whole thing is nutty.
Yep.
So the 260E makes a lot of sense in some regard. But now, as we've sort of standardized and methodized how we use Buchla systems and so on, it stands out as a bit of an odd duck.
Yeah. So let's let
what's it
people,
do?
Here, let's just turn it on for a second.
And that's it. Thanks for listening, and we'll see you. So it is a pitch class generator, which means that a pitch class is one note in all perceivable octaves. So as Kyle turns the potentiometer from A to A,
there's the low A that's on the
and you're hearing,
on the panel.
but you're hearing all of the A's.
Yeah.
In a range. I think this does a range of octaves, because as you turn the pot and you go up to, so it's up toward D and then E and F and G, and it comes back around to A again.
And we're back where we started.
We're back where we started, yeah. So there are 2 of those, and what do you do with the pitch class generator? Well, we're going to show some interesting things, But I think what makes this module so interesting to folks is the bottom section, the Escher's Barbershop.
Yeah.
And that is a really fascinating thing that I'm thinking, do I want to jump into that without providing any more context? Let's talk about briefly, Kyle, the difference between the 260 and the 297, because they both have Barber pulls on them. And in the 297 show, we talk about something that we have found out is kind of teasingly named Dave's Barbershop. And it does a Barber pull phasing. So, and we explained that in the 297. So it seems like it's forever rising in its
the phase shifting is ever going up or going down.
Yes. The 260 does a Barber pull of the pitch classes. So it lets you do the shepherd tone, the shepherd Risse glissando, the tritone paradox, and some other interesting auditory illusions. So while they came out at the same time, and one was, I'm going to say, stillborn, and the other went on to great success because of the 297. And folks get them confused. I got them confused at first. I bought a 297 expecting to get the shepherd tone out of it.
Yeah.
But they are very, very different.
Yeah, and also one thing to note too, if you're watching this video through Patreon or YouTube, you can see the 297 right next to it, and David kind of mentioned this, that at certain points they're having trouble finding the multiple LED setup for the Barber pole that's we're seeing on the 297, and like he mentioned. Sometimes he just had to do this LED one, so I think there's different versions.
Yeah, the 260 has the nice 297 style one, the 260 with the Rogans on it, which is funny because that Barber pole indicator is essential on the 260.
Yeah,
and not really that useful on the 297. I mean, it's useful, but like you could have just had the line of LEDs on the 297 and been fine. But when we're using the 260E, if you're watching the video later, it just is a vertical line of 8 LEDs that kind of remind me of the Altair 8800 vintage computer where you programmed down with the switches on the front. What do those LEDs mean? Mm-hmm. But the Barber pole indicator would have been much more useful, as people will realize as we start messing with that shepherd tone thing. So my favorite thing about it is also the thing I hate about it the most, which is the equalizer section. And I love it because you can get some incredible drones out of this thing. But I hate it because it's not under voltage control and it's not under preset management.
Yeah, it has the white tops on the knobs. So let's do that. We'll kind of work our way like top down from this. Yeah. So
this will be a mostly listening one, won't it? We'll just mess around with all the different sounds.
Yeah, so I'm bringing back up. So there are 2. So let's actually
pitch them slightly off. So we'll have them. They're not really detuned because they're independent oscillators or tone generators, and they have different pitch classes. So they're technically not detuned because you don't tune the pitch classes together.
Mm-hmm. You can.
You can, but I mean, like. Music mathematically speaking.
Yeah.
There's a lot of jitter too because the code is, what are these 1-bit resolution DACs and these things?
Yeah. You can definitely hear that. And that kind of jitter. Yeah, sometimes you just knock around. Yeah. And that'll maybe knock into some more jitter.
Or breathe hard on it.
Yeah.
So that's where you can start to hear the formation of a drone. Like now I'm going to do my favorite thing and turn down
So these
equalizers.
These equalizers, they're boost and cut. So why don't you cut everything? So straight
I'll
up,
cut everything.
they're like at 0. But if you turn them to the left, they cut the frequencies. Now Robert's going to go. So on the first one, which is boosting
150.
Yeah, 150 or below or something like that.
And then 500. That's mid, and then or unison, I guess, and then. So now you've got the makings of an organ.
Yeah.
Like these are almost like drawbars in a sense. We are shaping the organ sound. Hear that?
Just a clicky, yeah. And that's just, I think it's just overloading to the...
Yeah. Turn that down slightly. And then I'm bringing them all up.
I don't even have...
Ooh. Okay. What a great sound.
Let's turn the low pass gate up and down.
Yeah, so let's bring up the volume of just one of them.
Okay, I'll do the A.
Yeah, and then I'm going to put the cut, I'm going to add and boost the 150 and boost 500. And this is something I was telling Kyle about before I came over, or when I got over here. I like to use a chorus with this. So this will come through, right? Okay. So this is a really fast chorus. I'll turn the chorus down. So with this, you can get like a really neat, kind of a wobbly, sort of Boards of Canada type drone thing going on, which I really like. But then what?
That indeed. So what's interesting, as we kind of showed off, the knob starts at A and goes to A, and so it's just a weird kind of thing to process. Because if you think like, if I'm going to sequence an oscillator, you might jump around, 2, maybe 3 octaves, or
Yeah, I want to go below. So if I start at C3 and I want to drop down to D2 to add some bass or sub sound into there, but you can't do that on this.
It's already there. It's already
because it's all of the notes in that, and all of the octaves, all the perceivable octaves, which is really hard to wrap one's head around.
So yeah, if we we can add some pitch information. We'll just have a kind of random sequencer thing going from.
If anybody listens or watches Syriac's videos on YouTube, this sounds just like the music that Syriac uses for his crazy surrealism.
So yeah, we have this cranked up all the way on the input. I guess I can just start at A, because it's going to go up to A.
I'm going to bypass the chorus for this, okay?
Yeah.
So you hear it better. So you have, what's the pitch class at? Roughly D sharp?
Yeah.
Or E flat?
And then I'm going opposite ways. There is also to note, this has a center indentation on its knobs, which not, I don't know if all of them do. Do they on the 200E?
Yes. Oh. Well, no, you can't say all of them. A lot of them do. A lot of them do, but not all of them do. Like the 251E's master pitch multiplier thing does not. Mm-hmm. But a lot of the other ones do. Isn't it weird how when you turn that pot for the CV input, it adds a bunch and then it all disappears when you go to full?
Yeah.
Kind of like turning it up to A.
Bring in that second drone.
Turn my chorus back on.
Yeah, it sounds good with that.
Yeah.
That bass.
Yeah, the bass is just This is great. Yeah, that it's not really it's not an oscillator per se. I mean, it has oscillators in it, but it's not a waveform generator the way the 259 or 258.
I guess what we haven't kind of mentioned too, they're all I mean, these are all sine waves.
Yes.
So there's not a lot of harmonic content in them. So, I ran them through like the spectral programmable spectral processor model 296, the one that we featured on the last episode. And there's just not you can kind of use the attenuator sliders to just pull out like some of the like actual octaves, which is kind of neat. But going through like the program control to kind of sweep it around like a bandpass filter, it's not that I don't know. It's not worth showing here because it's just there's not enough harmonics for it to grab on.
Not coming out of the 260 by itself.
No.
But if you run it through all, 285, 291, 277, et cetera, and you add in harmonics, sure. But then you're not really talking about the 260 anymore.
Well, but
talking about an entire Buchla system.
Yeah. And it's like, and that's where ideally everything kind of, putting into a system will exponentially, further what you can do with your system. I kind of find it a little bit limiting in that there's, which is interesting, and I think about it as an oscillator, but I know that I shouldn't. But there's only one output per oscillator, which, most every oscillator, there's multiple. There's
one output per pitch class generator.
Yeah.
An oscillator is inside the pitch class generator.
Sure. Okay.
To create Yeah. It's an important distinction.
Yeah. But one audio output
yes.
per pitch class generator where
just about everything else has two.
Has two or multiple. So it's like if I want to try and like frequency modulate one with the other, on a 258, you can do that, but still run it, still have multiple audio outputs to hear what that modulating oscillator is doing.
Right. Like each section seems like it should have two outputs because oscillator A and the 259 has two, oscillator B does as well. It's duophonic pitch class generator, two pitch class generators, each with one output. So that is kind of
where it feels like
you can't cross modulate them.
Yeah, and I find like there's more as we'll kind of keep going, like running this through other audio processing modules can be helpful.
It's also cool as a way to provide FM modulation of other things too, because especially you don't get the shepherd tone generator from the top as you get the audio from the shepherd tone generator and you can use that to FM something else.
We'll show it. It's a little underwhelming.
Well, yeah. I've never seen Kyle with such a stern look on his face about a module.
Just to show off real quick, here I can pull out the.
I think the 226H utilities module would be more exciting for you.
It is kind of cool to give it. Because there is a FM audio.
Is it the speed
input.
You want for this?
Whatever, But you can add some vibrato. That's a little drunken. I might go a little.
Yeah.
But even when we kind of push it up into like.
And so if we turn the pitch class knob.
Oh yeah, it does have more effect. Yeah, because we had it all the way up at the upper A.
We'll cut out those higher harmonics there.
Change it to a square wave.
Yeah, kind of mess the sound that you can get just out of the most basic oscillators. I'm going to put all the equalizers back to where they were. Yeah, it's basically a vibrato, not much else. At this frequency for the modulation oscillator, the oscillator FMing it, Now what? Should we, if we run the marsh sequence with it, I'm going to plug that in before Kyle tries to create the patch he's making.
That's cool.
Yeah, the
square wave is
square wave
going slower and kind of, jumping that sequence around a bit. Just to show real quick, we can do the FMing B into the A. So here we go. Let's maybe turn off the
the sequence, yeah.
So I have this full up.
Yeah, that's some impressive FMing.
So there's like nothing.
Why? Are you? So
I don't know. It's just me. It's just the sign. Like.
Oh well. No, you should.
Perplexing, right?
It is. Underwhelming.
Yeah, it's like I'm changing around the frequency, but yeah, no go.
Well, we haven't talked about the bottom section.
Yeah, so let's move on.
This is the 90% of the cost of the module is in that that bottom. The bottom, the Escher's barbershop. That's how it's labeled. You've got Dave's barbershop on the 297 and Escher's barbershop on the 260E. And that makes sense. Well, the Dave part doesn't make sense unless you know the story. But
which
the Escher,
now we all do.
Which we all do, yeah. I'm going to scratch out mine and write David in there. But the Escher's barbershop, because we're talking about auditory illusions, that's what this thing does on the bottom section. And it's making reference to a lot of MC Escher's drawings where you have staircases that go up forever or go down forever. Mm-hmm. And so with this guy, Kyle, I had a 260E. You've heard me record it. It's on 7-waves and stuff. But I didn't really do the equivalent of Hans Zimmer, using the Shepherd tone paradox for the bat cycle. But what did you think of this? Before we explain what it is, how it works, what did you think of it when you started playing with the 260E?
So not the first time I heard it, where I thought it was clown music.
Yeah, but using it yourself, thinking, I'm going to put on my dark sparkler hat.
It was kind of like after the 4 minutes of messing around with it, it was kind of like, okay, it's just what it is. Where I look at so many other modules, we went over the programmable spectral processor, and we did 9 different.
It could have been a 3-hour show. Things
with it, and you were sure not everything is created equal in these modules, but I don't know. I always just am finding more functional ways to use it, and it felt limited for me, and not knowing just where to place that in my own musical sphere. I kind of just I get it for that kind of sound effect thing, sound design. Okay, I can be into that, but there's not enough there to then carry it to okay, what's part B going to be with this?
So when you hear it in Lost Atlantis, you're not really thinking, oh, that's a Shepherd tone paradox, unless you're really. I did, because I'm a nerd like that, but Barry mixed that in with all kinds of other sounds. He also programmed it himself with 258s,
and that's the thing too. So it's that's showing how using the whole system, you can get there, where this can get you there a lot faster, but how much control do you actually have over that?
It's not a starting point, I think, for a lot of things. And I wouldn't put it in a LEM 4. I mean, 4 space, But when it's used with all the other things in the ecosystem, in a 24U or even an 18, and you're using it for its job, for providing certain harmonics or certain sounds, it can be really great. But when it's taken by itself, it feels like a novelty, because it kind of is. And it's got some quirks and things, which I think will be fun to explore. Let me make sure. I got chorus off. So do you want to explain what the barbershop does and the octave division? And Give a demo there.
Yeah, so I'm turning both, so you're hearing both oscillators right now, and I can pitch these around wherever. But when we hit the open button,
which means opening the barbershop.
Yep.
How clever is that? You get kind of a Shepard, Risse, glissando thing from both oscillators, one going down and one going up.
I think they're both like...
Yeah, one's A's going down and B's going up.
Or they're offset from each other because
Yes.
they're not doing the same. Because there is a... if you're watching the LEDs on here, the LEDs are slowly going up, and we... so I guess just to map out these controls, we have the rate of change, which we have kind of dialed center, which...
minus 30 to 30?
Yeah, so if we go down, it's... we have semitones per second. So right now it's 30 semitones per second. But
Minus 30.
Yeah.
So going down 30 semitones per second.
And then this is...
Going up 37.
And then you can do...
You're going to overwhelm it, yeah.
So the other knob, which I don't really know if we actually have... I mean, I guess this is octave.
Well, it's 2 to 24. It's not really... The rate of change is semitones per second for...
For 2 octaves. So
Yeah,
then this is the octave.
Yes.
A knob, I guess a knob, so you can go... So I have it now set to 2. So
Yeah.
it's right now, it's maybe going 6 octaves... Or sorry, every 6 seconds it's going 2
6
octaves?
semitones per second,
Yeah. Oof.
right? So every second it's going 6 semitones in an octave.
Yeah.
We should explain what the Shepard tone is. That might help with it.
And now I'm turning this up to like 24 now, and we can hear it kind of going much faster. But they're interactive, so then it's like, we can go up to 18 semitones per second. I have this set up at 12. I can then... Nothing's really changing
Yeah.
when I'm
not even going to try to explain it. I don't know why. It probably has something to do with the way those auditory illusions work, with the inputs that we're providing to them, as opposed to making sense as an oscillator.
Yeah.
You're not dealing with frequencies. You're not dealing with modulation depth. You're dealing with the inputs to the math that results in, Roger Shepard, who the Shepard tone's named after, was a cognitive scientist. And so the experiment that he did that the Shepard tone's all about is an auditory illusion where you have all of the pitches in a particular set of octaves, the semitones increase by 1, and the low semitones are loud and the high semitones are quiet, because you are hearing all of the, all of them across multiple octaves. So as it goes, it sounds like it's forever going up, because by the time it gets to the high pitches, the low pitches are almost completely silent or some level of quiet.
And then the top ones
fade out. And the top ones fade out and the low ones come in again. So it always sounds like it's forever going up, which is, let's take out one oscillator. And that's it there. So that's the Shepard Risse glissando or Shepard tone paradox. And then you hear that little click because this is computer code. And I think that the resolution of the thing, making just totally spaced, but the resolution is like 2-bit or 4-bit, or there's a problem in the code. Because when you created this sound in Ableton, you'll get that tone when your algorithm doesn't have it's kind of like a crossfade.
Okay, yeah.
But in this one, it's just repeating that.
Like the cycle is like a hard...
Yes, because it's cycling
clip
it.
Or something, yeah.
Whereas on Ableton, you have, processors and a memory space where you could generate a Shepard tone that is 10 hours long and post it on YouTube, which somebody did. And so as we bring it up, you can hear now how the paradox works because it's so fast that your brain isn't being tricked into thinking it's the same sound forever.
Mm-hmm.
Now, some people say that it's way more pronounced descending, and some people think it's more pronounced ascending, but I guess that's because we're all wired differently.
Mm-hmm.
And this is the sound that Barry has in Lost Atlantis for, I think, about 10 seconds or so, as he's bridging between two different sections of the piece. It might be Trinity. I get a little confused, but as he's bridging between two sections, and I like to think that he kind of had this going on as he's unplugging patch cables and stuff to get ready for the. Yeah. So tell us about quantized and eccentric.
Yeah. So there's 3 different like octave division sections, and so we've been listening to the continuous, where it just kind of forever going. Then I can switch a button to go to quantize.
We'll speed it up a little bit,
and I'll give it more. Now we can hear
quarter notes.
Yeah.
Right?
Mm-hmm. It's more of a, instead of kind of that, them all kind of gliding together, we're hearing, specific changes in those quarter notes.
So you can still tell how it sounds like it's forever going up.
I'm bringing in the B oscillator too.
Yep. So there you hear you hear the Shepard tone paradox, but we took out the Ricet part of the glissando from that's in the continuous. Now here's an interesting thing that we didn't mention. There are 2 pulse outputs.
Yeah, so now, which they don't fire off in the continuous mode. They only fire off in this quantized, and let's do that.
It's slowing down and speeding up again.
It feels like that. I feel like every time I jiggle the table, it like these knobs feel very kind of.
Or is that sensitive. The illusion?
That's right. It could be. So now I've got the A and B pulse outputs going into quad function generator sections on the 281, and then into the low pass gate. And their attack and decays are kind of turned all the way down right now. Turn up the decay a little bit, but yeah, they just alternate, I guess, between.
Yep. That's what they do.
Yep. And then we'll go to this eccentric, which we learned is
tritone.
So we'll leave it the same settings. We have this kind of knobs, the rate of change kind of straight up, and then we'll leave it at around 12. Did we hear much change?
Not with the pulses and stuff.
Yeah.
Maybe if you take out the gating. So the tritone paradox, if I recall correctly, is the one where you're hearing a discrete different note, but you hear it as it's playing a discretely different note or semitone from what your brain thinks it's playing. If I remember that correctly.
Yeah, like right now at this setting that I have it at.
Too bad we don't have an oscilloscope or something here.
Yeah, I feel like it is kind of like every perceived cycle I hear, it feels like maybe the root of that change or like changes for me. The root.
Maybe.
So I've turned this second knob down to 6.
Let me turn the... That's fun.
Compared to...
the quarter notes, quantized.
Yeah, where like this just feels very like regimented in the tones that we're hearing. It's slower, because it's not giving us every single note.
And you can see the LEDs are largely meaningless. You see 2 LEDs and then 2 spaces between them.
Which those don't. Have those changed at
I think that they're relative.
It's always
yeah,
two. Or well,
whatever
no,
we
this
have.
one.
Oh, there. That sounds kind of cool. So if you're programming music for a slot machine or the Press Your Luck, new series, Press Your Luck, no whammy, no whammy, no whammy, no whammy, stop. Yeah. Yeah, it's like, no whammy, no whammy, no whammy, stop.
Oh my gosh. We know how they did it now.
So this is this guy. Let's take this 2 pulse things out. Let's play around with making. So we've joked about the sounds and stuff, but there are some really cool things we can do with it by manipulating the output, the audio output, with the 297 and the 258 or 285 and such. So you're the patchmeister for your system putting this stuff together. But we had some really, really crazy, gritty, wild sounds coming out of this earlier when we were playing around with it with the 297. Let's see if we can recreate that.
So we'll run this. Let's see here.
I think I had, yeah. Okay. So let me just choose the lowest one so we don't get jitter. So I'll turn on the phaser. I'm going to cut out the high harmonics. Boost the lower ones. Oh, we had the reverb going earlier when we...
Oh, yeah.
Yeah.
And if you may remember, or not, if you haven't listened to the 297 show, that input really gets kind of overdriven. And so boosting those bass frequencies really kind of like can make it pretty grungy.
It doesn't sound good at all.
One thing we could try doing is...
oh, yes, with the 288 time domain processor. Yeah, this was fun. Boost that to 10 stages. And cut the chorus.
And actually, let's turn on...
we were in continuous.
Yeah. Kind of set that slower. So kind of what we could do is record. So right now I have a loop going, so I can. Here's the recorded loop just by itself, and we can pitch that or down, and then blend that in with what we had. Grab a new loop. Oh, oops, gotta turn this back up.
I'm going to change the equalizers back to neutral here. Did the 288 record that distortion?
It could have, yes. Like if I... It's going to put its own kind of click when it resets its buffer loop too. So, are you all going mad yet? Turn on the chorus again.
Yeah, turn on the chorus. So that just adds this weird except for the clicking sound, which resets it. It's got kind of a neat. Yeah. Oh, I turned the phaser up way too high.
Yeah, it's a good amount of movement in there.
Oh, the quantize. Oh, the eccentric.
Yeah, click it over to eccentric just to. That's where it kind of
Yeah, that's it's kind of interesting too with the 288. Play that back over itself. Yep, that's. So can we expect a new double album from Dark Sparkler that is only the 260E?
No.
Double album, double vinyl?
No.
With liner notes?
It was great to talk with David about this because I think the key thing that he said was like, oh, it was a mistake. It wasn't really what he wanted. And so in my mind, it's the module for nobody.
Yeah.
Is how I am kind of thinking of it. Because I'm sure, just like historically, what we kind of even chatted about, Don would do a lot for musicians to like make these, help them realize the things that they want to do with their music. And so, it started with Mort and getting the whole 100 series going, and then, kept on evolving. And so where this was kind of just some cross wires and not really what David's intention was, but Don had obviously put a lot of work into it and just wanted to, follow it through. It wasn't.
It's cool.
It's cool, but it's like it doesn't have like a. I guess it doesn't have. I mean, this is like why we need. It'd be great to actually ask Don of like, what would you do? Like, what's your? I wonder if he used it for anything, any of his music.
Well, I mean, we've been kind of joking around about it because just playing with it, the way it comes out and distorting it and stuff is kind of, it's an island of misfit toys kind of thing. But really, you can use that for organ sounds. You can dial in an organ sound and have that as a drone, or have some slight modulation, or have a shepherd tone in one part of your music, of your song, of your piece. I think that for us, looking at the real estate in you have an 18U here, but even in a 24U, you got to make some complex real estate decisions.
Yeah. Yes.
And the 260E is a kind of a tough to make that call compared, especially if you have something like the Marf in there that's 4U, or a bunch of 2U stuff like the 252E and the 296E and the 227E. There's 6 right there.
Yeah. I mean, so where like in the 200E system, which it came, I obviously, I think of this as more a 200E module because it really didn't get released until then, where things got smaller in general. Like the Thunder touchpad is really like the biggest thing.
Yeah, three spaces wide.
In the E system, which you can have out of the system anyway. So you're only looking at 1 to 2 space modules. But yeah, still it's. I
mean, when it came out, there weren't a lot of modules to buy anyway.
Yeah, so it was part of it. Todd, I talked with Todd Barton, Take a Drink, and this was in his original system because that's he was early on adopter of it.
Now we have too much choice. Now we have so much choice that you do have to make that call about whether you're going to do a 260E or a clone or a MEMS thing or a completely new thing from Keen or from human comparator. Like that trade-off gets tough now.
Yeah.
So that becomes like a one-trick pony in a sense, where you're like, what am I going to have? You had to take out something to put that. Oh, my 251E. That's what it was.
Yeah. So four lane, sequencer basically.
So that colors I think the perceptions a bit.
Yeah.
But it on its own, it's like, okay, this is what it does, and it can make some pretty. You made a really cool video on Facebook that had a lot of timbral characteristics that folks kind of went crazy for. You know, some people are saying, "Oh, I wish I had that instead of the 297," or, you know, what is that? Is that a new module that you created?
It's right. Yeah, it's like the second video on the internet to ever come out about this thing. So, you know, it's intriguing, but my patience wears.
Yep, I could tell.
Wears out pretty quickly with it.
You were practically doing that hand thing to indicate
wrap it up.
Yeah, wrap it up. Right after I started talking about the outputs.
Wrap it up, B. So yeah, it's what it is. You know, it's a tone generator. It's not an oscillator. It does like a very cool audio illusion.
It's a good drone machine
with a little bug in there that will kind of
haunt you forever.
Clip. You know.
Somebody, when I posted a demo of this on SoundCloud some years ago, somebody said it was nightmare fuel, which I thought was
there's a
really because of that clown, you know, that organ grinder type. Mm-hmm. Oh, that's right. I told Kyle when I came over that if we had done this featured module the old way, where we each did our own demo of it, I was going to use it to make the theme song from Killer Clowns from Outer Space because it's got that.
And then I would have like inadvertently, somehow not knowing that, done the same with
the guitars. Yeah, you could have gone the whole way. Oh, man. Sine waves, you know, what are you going to do?
All right. So I guess we'll wrap it up there.
Yeah. Thanks for hanging out with the 260E today. It's been a long time coming.